So, uh, in digital electronic, we basically deal with binary systems. Binary systems. So usually in programming or in day-to-day life, we deal with the decimal system, right? So when we say binary system, decimal system, octal system, hexadecimal, it's nothing but the way how we represent a number. So when I say binary, it is a two-digit number. Like we can represent the number using either 0 or 1. Whereas in case of decimal numbers, what are the possible values we can represent? It starts from 0 and goes up to 9, right? So
Yes.
if I consider hexadecimal, hexa in the sense it is a 16, right? So ideally, what should I have represented? We should have represented like 0 to 16. But when I say it is 16, this will be like kind of two digits, right? So what for that purpose, what we do, 0 to 9, we represent same as the decimal. And from 10 onwards, what we do, like for 10, we represent A, 11, we represent B, 12, we represent C, so on. For 16, we represent it as F. Okay. So for 15, we represent as F because total 16 different values. The same way for the octal, like when we say octal, it is like 0 to 7. Okay. So and like based on like the number what we represent, like here it is like 0 to 1, the base value we say it as 2. Here base value is 10, and here base value is 16, and here base value is 8, right? So it's nothing but a symbolic representation. And actually, in why in electronics we study this binary system, that has a significance. All our computer systems or all our digital electronic systems, especially like you might have studied about gate, so many things you have studied, right? So I mean you will be studying, for example, because like if you are a digital electronic student, like initially we will study the gates and things like that. So here like you studied about analog system, but as a computer, right? Like for example you are typing something, or like for example I am speaking, and that is basically converted into digital format, and that will be transmitted to ethernet or internet. So for that, why only the binary system? Because when we say digital system, we have to, I mean, even though we say digit, like internally it has to deal with voltages, right? So in terms of voltages, it deals with either 0 volt or plus 5 volt. Okay, so the 0 volt is represented as 0, the digit 0, and plus 5 volt is represented as digit 1. That is the reason why we have more significance on the binary. Okay.
Yes, sir.
So first we need to understand how do we convert any number from binary to decimal, or decimal to binary, right? So I mean most frequently used conversion system in electronics is decimal to binary. Okay, so one common method what we use for conversion of a decimal number to binary is LCM way. In the sense, like for example, if I have a number something like 37, okay, what do I do? First, I need to divide this number by 2. So if I divide this number by 2, so what is the value here? Can you tell me?
18.
18. And one reminder I am going to get, right? So I have to write it here. And same way, if I divide this number 18 by again 2, it is 9, and remainder is 0. Same way, if I again divide this 9 by 2, it will be 4, and remainder is 1. And 2, 2, and remainder is 0. And 2, 1, and remainder is 0. So, I mean, further we cannot divide. So we have to read this binary number this way. We should start from this and go up to max. So here it is something like 1 0 0 1 0 1, right? So this is in binary. Clear?
Yes.
So this is the common system what we use for conversion of a decimal to binary, or for that matter, any number system, right? I mean, like octal, be it can be octal or like hexa. From decimal system, we use the same mechanism. So for example, now let me consider I want to convert from decimal to octal. Like if I say I have 97 in decimal. Now I want to convert into octal. So what I have to do? I have to divide by 8. So what is the value here after dividing by 8? What is the quotient?
12.
It is 1.
No.
Yeah,
1.
12, right? 12. And how many, what is the remainder here? 1.
1.
Correct? And again, if I further divide, 8 ones are 8 fours. So this will be actually become 4 is the
1.
remainder, 1. So 1 4 1 in octal system. Okay.
Yes.
Same way, now from decimal to hexadecimal. So let me consider a number 546. I want to convert into hexadecimal. So with which number I have to divide? 16. So what is the value here? 16 3 is a 48. So 6 will be remaining 66. So again 16 4 is a how much? 64, right? So 2 will be remaining, right?
Yes.
So here again I have to divide by 16. So what is the value?
2 is 32.
Right. 2 is a 32 and 2 will be remaining. So it is actually 2 2 2
16.
in the 16. So actually here, for example, there is a possibility that you may get something like 13 or 12 and all. So if you get like in that way, so actually 10 is nothing but A, 11 is B. So if you get 12, you have to mention C, 13 is D, 14 is E, 15 is F. So that way you have to, that is the only difference actually, I mean, in the hexadecimal, right? That you should remember.
Yes.
Now, how do I convert? So I know like how to convert from decimal to binary. How do I convert from binary to decimal? That is based on the positional system. So what happens is, so for example, like each position, it's a weighted sum. So if you consider any number, right, that is a weighted sum. Like when I say like decimal itself, so in your like primary school or high school, you might have studied the weighted sum. So for example, if I have something like 136, that is nothing but it we say it's a unit position, 10th position and 100th position, right? So it basically represents how actually I mean in decimal, right? This is nothing but 10 square into 1 plus 10 power 1 into 3 plus 10 power 0 into 6. This is the representation, right? Any number, when we represent as a whole, it is nothing but a weighted sum. Okay, that is the basic concept. The same way, when I say I have a binary number, this is also weighted sum, but with the base. So here, whenever I say it's a 10th base, that's where like I'm doing the weighted sum of the 10 to the exponential, 10 to the power some value. But here, it's a binary value, so it's a weighted sum. How many bits I have? Like it again starts from 0, right? So it is nothing but 1 into 2 power 0 plus 0 into 2 power 1 plus 1 into 2 square plus 0 into 2 cube plus 0 into 2 power 4 plus 1 into 2 power 5. It is nothing but here 32 plus 0 plus 0 plus 2 square is 4 plus 0 plus 1. It is nothing but 32 plus 4 is 36 plus 1. Somewhere I might have missed 4. Thirty-two plus 4. Correct. 32 plus 4 is 36 plus 1, 37. Correct. Right?
Yes, sir.
Yes. Same way, can you try this? 101. 101. Yes. How do I convert to decimal?
1 into 10 power.
Not 10 power, 2 power.
2 power. 0 into 2 power 1. Plus 1 into 2 power 0. 5.
It's 5. It's actually 2 square plus 0 plus 1. That is 5. We have a special case. We can have something like 0.101. This is a fractional binary we say. Okay. So wherever, like before this point is there, right? So we consider the nominal way. Like this is the 0th position. It is like 0 into 2 power 0 plus whatever is there after the fractional point, I'll be multiplying. So here the negative exponent will start. 1 into 2 power minus 1 plus 0 into 2 power minus 2 plus 1 into 2 power minus 2. So this is nothing but 0 plus 0.5 plus 0.125. Right? So this will become 0.625. This is a fractional binary we say. Clear, right?
Yes, sir.
Can you take another example on the fractional binary? You have to try 1, 1, 0 point. Sorry. Okay, 1, 1, 0.101. You can try this. So this is the reference point. So 1 into 2 power minus 1 plus 0 into 2 power minus 2 plus 1 into 2 power minus 3. So here you have to go reverse this.
6.625.
Yes. So 0 into 2 power 0 plus 2 power 1 plus 2 square. This is 4 plus 2, 6. And here you will get 0.625, like same as previous, right? 6.2. Clear with conversion, right? Both the ways.
Yes, sir.
Yeah. So use same concept. We have to convert into binary to octal. Okay. Binary to octal. But here it is a little tricky. Okay. But still, let's see how do we do that. 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0. So this is in binary. So So actually, one easier way, I mean, without remembering anything, how you can go is convert this directly into decimal first. If you want to convert into decimal, what you have to do? You have to multiply by 8 to the power 0, 8 to the power 1, 8 to the power 2, that way, right? Then from decimal, you can convert into octal. This is one way, right?
Yes, sir.
But it is a tedious way. It takes a lot of steps. So easier way, what you have to do from LSB, okay? From LSB, you have to divide 3 bits. Okay, divide 3 bits. From LSB, you have to divide 3 bits. When you divide 3 bits, so 0, 1, 0 is nothing but what is the value? It is a 2, right?
Yes,
In
sir.
decimal or octal, anything, it's 2 actually.
Mm.
1, 0, 1. It is nothing but 2 plus 2 to the power 1, that is 0. 2 plus 1 plus 2,
5.
that is 5. 2 square, 5. So this one,
2 plus 4, 6.
6. So this will be in octal. You have to divide 3 bits and then convert into, I mean, if you see in the decimal also, for the 3 bits, maximum it can go up to 7. So anyway, if you convert into decimal, that will be in octal only. Clear?
Yes, sir.
Okay. Can you convert this value? So here it is little tricky. One important fact you have to remember in this, I'll let you know. 10110 and then 10. So here from LSB you will start, right? Dividing 3 bits. So anyway, here like you don't have 3 bits, you have to add 3 more bits. So it's 3. So here after point, we have to start dividing in the right side from left to right. So 101 and 101. Then only 0 is remaining. We add in the 2 bits. So this will become 0. What is 101? 5. Correct?
Yes.
Hello? 101,
Yes, sir.
5. And here it is 0. 0.550. That is in octal. This is clear, right? You're getting now how to do.
Yes, sir.
So you have to divide from right side, left to right. Okay, you take this example. Let's see how your understanding on this concept. Based on that, like we will move forward. So 110, 10, 10, 10, point 1011010. Convert into octal.
$652.55.
Good. That's right. Same way, another method like binary to hexadecimal. That is also most popular way of conversion. So 1111 101 10010. This is in binary. I want to convert this into hexadecimal. So here from left to right, instead of 3, here I have to divide 4. Okay. So what is 10010? That is 2. Correct. So what is 1011 in decimal? 1010 is 10. 1011 is 11. But what is the equivalent of 11? 10 is A, 11 is B.
B.
What is 1111?
15. F.
F, right? FB2. Okay. Same way, you can try same as octal concept. You have to apply. So here it is from left to right. After point, it is from right to okay. Actually, from right to left in case of integer, fractional from left to right. So just take this part. I'll write here 0.010110 1111011. Convert this. So here you have to stick 4 from left to right. So here it is again 4. What is 1011?
5.
No, it's not 1011. Is not.
Not that. Okay.
It is 11. 11 is nothing but B, correct? 111, 7. 101 is 5. So it is 0.57 B.
Yes.
So we saw like decimal to octal, from octal to binary, right? So binary to octal, we then actually octal to binary is straightforward. Nothing much difficulty in that. So if I take so if I have 3, 4, 7, so 3 bits I have to keep adding for binary. So what is the 3, 4, 7? 3 is 0, 1, 1. So what is 4? 3 bits. 1, 0, 0. Correct?
Yes, sir.
What is 7? 1, 1, 1. So at least right 0 to 16, 0 to 15, you remember the binary value. So it will be very easy to conversion. Right? So quickly you can convert.
Yes.
You are EC student or a CS student?
EC, sir.
Oh, then this is very important. When not only in the engineering, after engineering, if you join as a profession, right? So every day we will be using it. It's very important. Now it's at least like till 16 you remember, 15 you remember. That is the 347
Yes.
dot 345. How to convert? So what is
So
the
we
value
should
of 3?
for minus
0, 1, 1, and 4 is 1, 0, 0. 7 is 1, 1, 1 dot 3. It's again 0, 1, 1. 4 is 1, 0, 0. 5 is 1, 0, 1. Hope you got an idea.
Yes, sir.
So octal to decimal. So octal to binary we saw. Octal to decimal, if you want to convert, it's a simple way. 3, 4, 7, if I say I want to convert into decimal, 3 into 8 square plus 4 into 8 plus 7, 8 power 1 plus 7 into 8 power 0. And if I had something like 2, 4, 3, 4, 7 dot 5, 4, then after dot 5 into
Minus.
8 power minus 1 plus 4 into 8 power minus 2. Okay, same way for hexadecimal also. I mean, hope I'll not explain again that part. Like, since you're clear, right, on that end.
Yes, sir.
But one special case, let me consider octal to hexadecimal. Octal to hexa. So when I say like 2, 4, 5, this is in octal. Then if you want to convert into hexa, directly it is not possible. I mean, one way is like from decimal, from here you have to convert into decimal, and then you have to convert into hexa. But alternatively, instead of converting to decimal, since that is like again you have to divide and all, easier way is to convert to binary. 2 is nothing but 0, 1, 0. 4 is nothing but 1, 0, 0. 5 is nothing but 1, 0, 1. 3 bits. Now from left, right to left, split 4, 4. It is 0, 1, 0 and 0, 1. Yeah. Here you have to split again. So 1, 0, 1, 0, 0, 1, 0. Right? So this is 5. This is A. So this is nothing but A5. Correct?
Yes, sir.
So this is a simpler way. Octal to hexadecimal. Same way, if they ask you to convert from hexadecimal to octal, like for example, A7D into octal, what you have to do? First, you have to convert into binary. A is nothing but 1010. Then 7 is 0111. D is how much? 1101. Okay, 1100 is C, 1101. So then split 3, 3. So this is nothing but 5, 7, 1, 5 in octal. Simple, right?
Yes, sir.
Okay. Okay. Take some examples. Like quickly, I'll ask summarize the whole session. So, what is the binary equivalent of 255? What is the binary equivalent of 1C in hexa? Okay. So, what is the binary equivalent of hexadecimal B1B6? This you can take as an assignment. Okay. What is the what is the hexadecimal equivalent of decimal number 129? So what is the decimal equivalent of 110101? What is the hexadecimal equivalent of 1001? What is the binary equivalent of decimal number 28? What is the hexadecimal equivalent of decimal number 35? What is the what is the decimal equivalent of hexadecimal number 7? What is the hexadecimal equivalent of binary number 1101101110? These things you can try. Clear?
Yes.